The required distance between stage lights depends on the specific lighting fixtures and the type of performance. Generally, it is recommended to maintain a minimum of 6 feet, or 1.8 meters, between stage lights and any flammable materials. Wire troughs should be spaced at least 6 inches, or 15 centimeters, apart to prevent cable damage and potential electrical hazards. Incandescent lights can be used without thermal protection in enclosed fixtures where the temperature will not exceed 90 degrees Celsius or 194 degrees Fahrenheit. A 55-gallon oil drum would typically be classified as Class Roman III. This classification is assigned to flammable liquids with a flash point between 200 degrees Fahrenheit or 93 degrees Celsius and 250 degrees Fahrenheit or 121 degrees Celsius. An industrial receptacle that is not in use should have an amperage rating of 0 amps. This means that the receptacle is not connected to any electrical circuits. GFCIs, or ground fault circuit interrupters, are designed to trip within 25 milliseconds or 0.25 seconds where a ground fault is detected. Let's delve further into each of these topics to gain a more comprehensive understanding. Firstly, regarding stage lights, the 6-foot or 1.8 meter minimum distance from flammable materials is a general guideline. The actual distance may need to be greater depending on the wattage of the lights, the type of materials used on stage, and local fire codes. High wattage lights generate more heat, increasing the risk of ignition. Similarly, some stage materials are more flammable than others. It's crucial to consult with a qualified electrician or fire safety professional to determine the appropriate spacing for a specific stage setup. Factors to consider include the beam angle of the lights, the presence of any curtains or drapes, and the ventilation in the stage area. Adequate ventilation can help to dissipate heat and reduce the risk of fire. Secondly, concerning wire troughs, maintaining a 6-inch or 15 centimeter spacing is vital for preventing cable damage and electrical hazards. Wire troughs are used to route and protect electrical cables, and overcrowding them can lead to overheating and insulation breakdown. This can result in short circuits, ground faults, and even fires. The 6-inch spacing allows for adequate airflow around the cables, preventing heat buildup. It also provides sufficient room for maintenance and inspection. When installing wire troughs, it's important to follow the manufacturer's instructions and all applicable electrical codes. Proper grounding is essential to ensure that any fault current is safely diverted to ground. Thirdly, about incandescent lights and thermal protection, the 90 degrees Celsius or 194 degrees Fahrenheit temperature limit is crucial for preventing fires. Incandescent lights generate a significant amount of heat, and if they are enclosed in a fixture that does not allow for proper ventilation, the temperature can quickly exceed this limit. This can cause the insulation on the wires to melt, leading to short circuits and fires. Thermal protection devices, such as thermal cutouts or fuses, are designed to interrupt the electrical circuit if the temperature exceeds a safe level. However, these devices are not always required if the fixture is designed to dissipate heat effectively. For example, open fixtures or fixtures with built-in ventilation may not require thermal protection. Again, consult with a qualified electrician to determine whether thermal protection is necessary for a specific lighting installation. Fourthly, let's examine the classification of 55-gallon oil drums. The Class Roman III designation indicates that the oil drum contains a flammable liquid with a flash point between 200 degrees Fahrenheit or 93 degrees Celsius and 250 degrees Fahrenheit or 121 degrees Celsius. The flash point is the lowest temperature at which a liquid can form an ignitable vapor. Flammable liquids are classified based on their flash points, with Class I liquids being the most flammable and Class Roman III liquids being the least flammable. When handling and storing flammable liquids, it's important to follow all safety precautions, including storing them in approved containers, providing adequate ventilation, and avoiding sources of ignition. Class I liquids have flash points below 100 degrees Fahrenheit or 38 degrees Celsius. Class Roman II liquids have flash points that are above 100 degrees Fahrenheit or 38 degrees Celsius and below 140 degrees Fahrenheit or 60 degrees Celsius. Glass Roman 3 liquids have flash points at or above 140 degrees Fahrenheit or 60 degrees Celsius and below 200 degrees Fahrenheit or 93 degrees Celsius. And as mentioned, Glass Roman 3b liquids have flash points at or above 200 degrees Fahrenheit or 93 degrees Celsius and below 250 degrees Fahrenheit or 121 degrees Celsius. Fifthly, the amperage rating of an unused industrial receptacle should be 0 amps. This is because the receptacle is not connected to any electrical circuit and therefore is not drawing any current. It's important to ensure that unused receptacles are properly disconnected and energized to prevent accidental contact with live electrical parts. This can be achieved by removing the circuit breaker or fuse that supplies power to the receptacle. Alternatively, the receptacle can be physically removed from the electrical system. It is important that all electrical work is performed by a qualified electrician. Leaving a receptacle energized but unused poses a significant safety hazard. Someone could accidentally plug in a device, potentially overloading the circuit or causing a short circuit. Furthermore, an exposed energized receptacle could be a shock hazard, particularly in wet or damp environments. Finally, about GFCI trip times. GFCIs are designed to trip within 25 milliseconds or 0.25 seconds when a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are designed to quickly interrupt the electrical circuit to prevent serious injury or death. They work by monitoring the current flowing through the hot and neutral wires. If there is a difference of more than 5 milliamps, the GFCI will trip, cutting off the power. GFCIs are commonly used in bathrooms, kitchens, and outdoor areas where there is a high risk of electric shock. They should be tested regularly to ensure that they are functioning properly. The National Electrical Code, or NEC, requires GFCI protection for receptacles in certain locations, including bathrooms, kitchens, garages, and outdoor areas. This requirement is intended to protect people from electric shock hazards. The NEC is a set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA. Compliance with the NEC is essential for ensuring the safety of electrical systems. In summary, understanding these electrical safety principles is crucial for preventing accidents and protecting lives. Always consult with a qualified electrician for any electrical work and follow all applicable electrical codes and safety regulations. Remember, electricity can be dangerous if not handled properly. Therefore, it's important to take precautions and be aware of the potential hazards. By following these guidelines, you can help to ensure a safe electrical environment. The topics discussed cover a range of important electrical safety considerations, from stage lighting to GFCI protection. Each area requires careful attention to detail and adherence to established safety standards. By understanding the principles behind these standards, individuals can make informed decisions and take appropriate actions to mitigate risks. The goal is to create an environment where electricity can be used safely and effectively. Continuous learning and staying up to date with the latest electrical codes and safety practices are essential for anyone working with or around electricity. Electrical safety is not a one-time effort, but an ongoing commitment to protecting oneself and others from harm. It is important to note that electrical codes and regulations can vary depending on the location. Therefore, it is always recommended to consult with local authorities or a qualified electrician to ensure compliance with all applicable requirements. Furthermore, manufacturers' instructions for electrical equipment should always be followed carefully. These instructions provide important information about the proper installation, operation, and maintenance of the equipment. Ignoring these instructions can lead to safety hazards and equipment failure. In addition to the topics discussed, other important electrical safety considerations include proper grounding, surge protection, and arc flash protection. Grounding provides a safe path for fault current to flow, reducing the risk of electric shock. Surge protection protects electrical equipment from voltage spikes that can damage or destroy sensitive electronics. Arc flash protection protects workers from the intense heat and energy released during an arc flash event. Arc flashes are caused by short circuits in electrical equipment and can result in serious burns and other injuries. Therefore, it's important to implement appropriate arc flash protection measures, such as wearing personal protective equipment and using arc flash-rated equipment. Electrical safety is a shared responsibility. Everyone who works with or around electricity has a role to play in preventing accidents and ensuring a safe electrical environment. By working together, we can create a culture of safety that protects everyone from the hazards of electricity. Remember, when in doubt, always consult with a qualified electrician. They have the knowledge and expertise to safely handle electrical issues. And never attempt to perform electrical work unless you are properly trained and qualified. Electricity is a powerful force, and it should be treated with respect.